Welcome to this explainer. Okay, today we're doing a total mindset upgrade. We're taking you from, a general AI enthusiast and turning you into a strategic, big picture Azure AI architect. If you're gearing up for the AI-901 beta exam, well, you're in exactly the right place. Let's break down the official study guide and uncover exactly what you need to know to absolutely crush this exam. So here's our game plan. It mirrors how a true architect actually builds a solution in the real world. We're going to hit the exam mindset, prioritize responsible AI, match models to workloads, route chat and agents, and finally wrap up with multimodal implementations. Let's dive right in. All right, section 1, the exam mindset, thinking like an architect. Right off the bat, we need a complete perspective shift. When you're sitting for this exam, you've got to look at operational dependencies, not just, writing cool code. And here's the ultimate trap. Assuming a generative chat model is the magic bullet for literally every single language or data extraction task. Seriously, it's like using a sledgehammer to drive in a tiny screw. The AI-901 exam expects you to surgically match specific workload needs to precise model capabilities, rather than just blasting every problem with a generic chat prompt.
Moving on to Section 2, Prioritizing Responsible AI, the Policy Lens.
Let's tackle our first major dependency, which is governance. Look, a technically flawless solution is still an absolute failure if it hides its limitations. Think about these failure states for a second. An app might spit out brilliant, eloquent answers, but it fails ethically if it's missing a grounding disclosure. Basically, a grounding disclosure is the AI showing its work, telling the user exactly where it got its facts. Without it, you get dangerous overtrust. Or what if unnecessary personal data leaks into your prompts? That's a massive operational failure, no matter how powerful your AI actually is. Now, pay attention, because here's a massive confusion alert for the exam. When you see keywords like fairness, privacy, or transparency, listen closely. Never, ever choose a larger model deployment as the fix. It's a classic developer mistake to think throwing a massive, expensive, GPU-hungry model at a privacy problem will somehow just magically solve it. Actually, scratch that. Tweaking a system prompt to have a friendlier tone does absolutely nothing to manage real risk either. Your blocking dependency here is always going to be governance, evidence, and applying the right safety controls.
Okay, Section 3, Matching Models and Workloads, Proving Capability.
Once governance is locked down, we shift to matching the source input to the exact workload pattern, and we do this before we even touch a technical parameter like temperature or top P. You're going to want to memorize these specific action verbs. They are literally practical shortcuts to the correct service family. If a scenario asks to transcribe, you need speech to text. If it asks to synthesize, well, you need text to speech. Recognizing these verbs right away stops you from making the classic rookie mistake of generating speech when the user actually just needed to be heard. And this builds perfectly into the concept of transformation direction. A huge exam trap is choosing an adjacent but slightly wrong workload. Picture this: a finance app reading uploaded invoices to pull out the vendor name, date, and total. If you lazily just throw a generic chat model at it, it might give you a nice conversational paragraph summarizing the invoice. But guys, that's a failure. The business needs structured data for a database, not a chatty summary. You absolutely must match the input data to the exact output shape the application demands. Moving to Section 4, Routing Chat and Agents, Step-by-Step Execution. Next up, we arrive at the largest domain of the AI-901 exam, practical Microsoft Foundry implementation tasks. I'm speaking directly to you as an engineer right now. Before you touch any code or build a lightweight client, you have got to validate your prompt and your deployment in the Foundry portal playground first. It's absolutely crucial. Separate the prompt behavior from the runtime routing. Prove it works on the portal, then make sure your client is calling that exact object. And that triggers another critical confusion alert. Imagine you successfully test a chat model in the playground, but then your newly built app throws a deployment not found error. The immediate developer instinct is to panic, tear apart the code, or completely rewrite the prompt. Don't do it. If you get a routing error like a 404, stop and verify. Make sure the endpoint, the deployment identity, and the credentials in your code exactly match the tested deployment in Foundry. I promise you, it's almost always a routing mismatch, not a prompt issue. Finally, Section 5, Implementing Multimodal Solutions, Directional Transformations. We're going to round out our architect's journey by looking at adjacent workloads in vision and speech. And here, transformation direction is literally everything. Vision interpretation goes from image to answer. Image generation goes from prompt to image. So if your app needs to analyze a photo of a broken control panel to find a warning light, using a prompt-to-image model is, well, it's like asking a painter to fix your car engine. It's completely backwards. You need a deployed multimodal model that can actually interpret the image.
We see the exact same logic with speech solutions too. Say a call center app needs to review recorded customer calls. You have to execute a speech-to-text transformation first. You simply cannot shove raw microphone audio into a text-only chat deployment without that initial conversion. So the golden rule here? Always establish the direction of the transformation before writing a single line of code.
Going back to our earlier example about pulling vendor names from invoices, this is exactly why Azure Content Understanding is the correct tool for the job. It uses a rigid schema to capture structured fields alongside confidence scores. And this is a game changer because it allows your app to easily map the data into a database or flag it for human review if the confidence is low. This kind of precision completely outperforms a generic unstructured chat summary. You get exactly what you ask for in the exact format you need. To wrap up this explainer, I want to leave you with a final challenge for your brand new architect mindset. Imagine a medical-adjacent chatbot that's saving full user prompts, including highly sensitive personal details it doesn't even need to function. As the Azure AI architect, what's your first move? Are you going to increase the model's context length to handle the extra data? Or do you step in, minimize data collection, and force a strict privacy review? Before you walk into that exam room, make sure you know exactly which priority takes precedence. Good luck and keep thinking like an architect.